Okay, so this is one of the harder examples that you can get. So we're just sort of going to take it bit by bit. There is quite a lot of steps to it, but to be honest, actually quite nice and quite easy to understand once we start going through it. So this is a question where you've got to describe what's happening, but obviously we're going to be using Suvat to be able to do that. So to begin with, we've got a car, it's travelling at a constant speed, so that means I'm going to be using Suvat. And we're told that it's going at 13 meters per second. Okay, it's got this bit, but actually that doesn't really make a difference. We don't need to know how many miles per hour it is because it needs to be the SI units. Okay, the driver sees a pedestrian 55 meters ahead. The reaction time is 0.5 seconds. That bit's really important. The car decelerates at 10 meters per second to the -2. What happens? So the first thing we've got to do is take into account the 0.5 seconds. So we need to see how far he travels before he even touches the brake. Okay, so to do that, this is saying how many meters he does per second. So we're just going to do 0.5 times 30, which is 15 meters. Okay, so that's how far he travelled within that reaction time. Okay, I'm just going to write reaction time here. So if you notice at 55 and he travels 15 in that part, we need to work out how many meters are actually left. And to do that, we do 55 take away the 15. Okay. Okay, so the pedestrian is 40 meters away when braking. Okay, so thinking at diagrams, you've got a pedestrian. I'm going to try and draw a car. Actually, it's not too bad. Okay, so start braking. We know that they're 40 meters away. We know that the speed of the car is 30 meters per second to the -1. And we're told that the acceleration is this. So that will be negative because it's slowing down. Okay, so using Suvat. So we know that that's 40. We know that it was travelling at 30 meters per second. We know the acceleration is 10. Now what we need to find is the speed when he meets that person, okay? If that number is bigger than 0, then it means that he hasn't managed to stop in time. If it is negative, it means that he would have stopped in time and essentially would have gone back. Obviously that wouldn't really happen in real life, he would have just stopped, okay? So back to our equation. So we've got the S, the U, the V and the A. So that means I'm going to be using number 4. Okay. So V is what we're looking for. U is, that'll be 30 squared plus 2 times acceleration, so -10 times 40. So that's going to be 900 subtract 800, which is 100. Okay, so that's all V squared. And then we have to square root it. So V is 10. Okay, so at that point when he meets a person, he's travelling 10 meters per second, which means that the car what's the word? I want to say collide, but that's not a very nice word. Doesn't manage to stop in time and hits the pedestrian. Okay, so it's good that you need to write a little blur at the end because that's what it's asking us to actually explain what happened.